Bless you. Okay, so I guess it's recording. All right. Come on, DocuCam. What's going on here? So I'm going to be helping you with the notation a little bit because it can get really confusing, but really keep this in mind. All of what you see on this particular page means the exact same thing, okay? Okay. So here's what I want you to write down your notes. Continuing from kind of where we are in our board here, it's of course section 3.1, derivatives of a function. Derivatives of a function. What's funny is what you guys have been doing this whole time, like what you just did on the board, you found the derivative of a function. You've been doing it this whole time. It's just now we have a little bit more formal notation. I've been asking you to take the limit as h approaches 0 of f of x plus h minus f of x over h at some point x is equal to. I'm going to leave like a blank space, right? This is the same thing, so I'm going to put like a bullet point here and say this is the same thing as saying, I'm going to put dot, 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 y prime when y is equal to, what is it, y is equal to, in our case it was like 3x minus 12, right? Or we can say dy of dx, which means if you look up here, well, bless you, if you look up here, the notation here, I'm not going to write the whole thing down, but it literally, how you're supposed to say is dy dx, dy dx, or I might say the derivative of y with respect to the variable x. Okay? dy dx, again, when y is equal to 3x minus 12. Or you might see it as df over dx. And then this time is when we don't call it the y anymore, sorry, but it was when we call our function f. When f of x is equal to 3x minus 12. This is just our example, okay? This is just an example function, right? Then we also have this last one here. So how you're supposed to say this is the derivative of the function with respect to x. Again, the derivative of f, df, derivative of the function with respect to x. So if you have a little bottom portion that says dx, it says with respect to whatever your variable is, the independent variable, the input value, okay? In this case, our input value is x. Get it? That's where we put in a value, and then it spits out a output value, a y or an f, okay? Or you might even see it like this, the df of x with respect to x. But in either case, they all mean exactly the same thing. Take the derivative of 3x minus 12. Even what you've learned in the very beginning of this school year, in like the first few weeks, this is still the same thing. Take the derivative of f of x, if your f of x is 3x minus 12 or whatever it is, okay? So I recently just altered your cover sheets, okay? So would you like to see what I altered with it? A minor adjustment. And I'm sorry for anybody that's actually doing their really diligent work, because you're going to be like, I just did 3.1, Mr. Wei. And all I can say is I'm really sorry about that. You don't have to go back and practice these problems, or like, you don't have to do the problems I just put on. I took out 4 problems. I put in like 3 other ones. But if you don't want to do the 3 other ones, it's fine, because you actually just did one on the board, right? That's number 9 right there. So I'll show you what I mean. Okay. I'm just spitting out random things and you're not really understanding what the heck I'm saying, right? So if you can't take a mental note, take an actual physical note and tell this to yourself, okay? On section 3.1, all I took out was the first 4 problems, numbers 1 through 4. So right there, I even put it in red so you knew, and hopefully I even put in a little side comment letting you know what thing I just altered. Oh, it looks like two of you guys, or I don't know who it is, but two of you guys are looking at it right now. So it's pretty cool. So numbers 1 through 4 is what I took out. It was the assignment used to be number 12, but now I made it 9 through 12. Okay, so again, numbers 1 through 4 are gone. Now it's 9 through 12. I added 9, 10, and 11 basically. And then why did I do that? I will show you why. Numbers 1 through 4 dealt with this. The derivative at a point. We've actually already done stuff like this before. And not only that, they're saying applying an alternate definition. I don't want to do that because it's just going to add more confusion to it. In case you did numbers 1 through 4 already, you might have seen that it's like, okay, this kind of threw me another curveball to what I already have been doing this whole time. I don't want to make you confused even more, okay? I think what you've already learned up to this point takes a lot of time to understand, right? f of x plus h, all that stuff can get really muddled with now I'm putting in the variable a, okay? It's just too much. So, and not only that, the A/B test, I don't ever see them using this form at all. I've never seen that before. So I'm deciding this year I'm not going to do it because it just adds more confusion to the chaos that you're having to deal with already, right? So instead, what we just did was 3x minus 12, right? Find f prime of x. So sorry, I guess that's another form I didn't put in. So you might have this. Let's write one more thing in our notes here. You might have f prime of x when f of x is equal to 3x minus 12. F prime of x. What I'm trying to say is 9 through 12, it's just asking to take the derivative or the limit as h approaches 0 of 9, 10, 11, and 12. None of them are tough if you look at them, okay? It's just you do the x plus h technique, right? None of them are tough, okay? So that being said, don't do numbers 1 through 4, go to 9 through 12, and then we're going to start on some new stuff here. Emily, could you get to the door for me, please? So, okay, so let's have a look here. Okay, so the next subject that I want you to write down your notes is graphing the function from a f prime function. So hopefully you understand f prime means I'm the derivative of, the slope of, right? And these type of problems ask you to sketch a graph of a continuous function f, knowing that with this fact, f of 0 is equal to negative 1. In other words, if you had a coordinate of x equals 0, its y value would be negative 1, okay? And here would be the graph here. So you're given a slope, okay, of 1 and 2. It's a piecewise function of x is less than negative 1 and x is greater than negative 1 here. So you need to find a sketch of a graph. You need to sketch a graph of the actual function. So you got to go backwards. You have to go backwards from here and give me so you want a graph of just f of x. Anybody kind of lost in what I just asked for? That's really weird. So write this down, and then I'm going to show you sort of like an example of what I mean, right? Okay. Don't worry, don't write this down. This is just like a side note here. If I had a xy axis here, and you guys, and I gave you that, remember I told you that slope, right? If I gave you a graph of the slopes, or f prime, right, and f, and I wanted you to go back to 1, 2, 3, 4, 5, 6, right? let's go backwards, okay? This is a graph for the slopes, right? A graph of the derivatives and slopes of this original f, okay? What is this? What would you say the equation for this line would be, roughly? Yeah. Yeah, sorry. Each tick mark is an increment of 1, so that's correct. What? Can you tell me, Stephanie, if this represented the graph for the slopes and at every single individual x value, it says that the slope is 3, what graph should I expect on the original f graph? Why would it be a line? Does that kind of make sense what I just did there? If I told you that every single x value, its slope was 3, okay? The f slope, the original function slope, was 3 at every single x value. So this is how we're going to have to interpret this. If I was given a list of all the slopes and they're all consistently 3, that means on the original graph itself, on the original f, not f prime, but the original f, at every single x value, if I took the slope at every single point, the m, the slope, should be 3. Does that make sense? So if it's always a constant 3, then you can automatically suspect that you're dealing with a linear function, okay? It's only when f prime starts, it's only when f prime is like this is where you start to worry what your function originally might look like, okay? So yeah, the slope's constantly changing. Sure. Okay, yeah, I'll draw that then. Yeah, every single x value here, if you can tell, the slope is now like at 1, right? Then here it's like 2, here it's at 3. If you're seeing what Stephanie is saying, that every single x value seems like the slope is at a higher value, then here what you're going to find is the slopes at those x values look like this, and you should get what looks like an exponential curve, okay? But I just want to stay here for now. But it's true, like Stephanie is right. If you have the derivative slope or the derivative graph telling you that you're having a constantly growing slope, that means on the actual f graph, then that's what it should look like, a line where its slope is constantly changing, okay, abruptly. And that's what we call an exponential curve, okay? All right, so let's go back here, and then let's focus on what this should look like. Any predictions on what this is going to look like, a piecewise function? I need to sketch the graph of a piecewise function that's continuous, and we actually kind of hit this point, f of 0 as well, is equal to -1. And it looks like from the left of this, it's as it's approaching -1, we have a slope of 1, and then over here we have a slope of 2. What the heck is that going to look like? Any thoughts on what this should look like at all? Okay. Maybe none yet, but let's try to think about this logically, right? And what I'm going to do is I'm actually going to find the equations for each of these guys going backwards, right? So if I have the derivative is equal to 1 and 2 of these guys here, then let's focus on this equation first. This equation. This equation, I'm going to say that the slope is 1, right? The slope is 1. It's telling me that the slope is 1. The derivative at this point is going to be 1. And then I have this xy point, 0, -1. How can I find the equation for this line using these two things? Well, I can use conveniently the point slope formula, which is y minus y1 is equal to m times x minus x1. And then I have the necessary components to make this linear function, because I detect it's a linear function because the slope is 1. So it would be y minus y negative 1 is equal to 1 times x minus 0, which would give me y plus 1 is equal to 1 times x. And then if I subtract 1 from both sides, that's y is equal to x minus 1. So this tells me that even though they gave me a slope of this function here, the actual function f of x is actually going to be equal to x minus 1. So again, f prime of this guy here when x is less than negative 1 is 1. But the f, not the f prime, the original f would be then equal to x minus 1. Let me see if I can find another pen here. Let's do the next equation in purple. Whoops, sorry, here. In purple. And then here, its slope is telling me that I have a slope of 2. And again, if it's a continuous function with the point 0, 1, what can I use as my coordinate here? Well, I originally used 0, 1 over here. And since it's a continuous function, they're both going to share that same point. So that same point's just going to be 0, 1 again. 0, negative 1. And I'm going to plug it back into that equation again. So it's going to be y minus y1 is equal to m times x minus 0. And then it's going to be slightly different, but you're going to plug in minus 1 over here. And the slopes where it's going to be slightly different. Now you're going to put in the 2 here, x minus 0. You're going to have y is equal to 1 is equal to 2x. And you're going to subtract 1 from both sides. You have y is equal to 2x minus 1. And the whole point of this is to sketch this. This is really, really drawn out and tedious. But if we wanted to see what that looks like here, are we good at writing this, or do we need a little bit more time to write this down? Yeah, we need a little bit more time to write this down. I'll give you like a few more minutes. I'm going to show you what this ends up looking like, and then after that, I'm going to give you your own problem to do, okay? I would say stuff like this is more complicated. All right, a few more seconds. Okay, I'm now going to move on and then show you what that graph is going to look like. So let's take a look here. You don't have to draw this, but you may. This is the graph. 1, 2. I'm going to make increments of 1 here. I know that's not equally spaced, but I'm going to try my best to equally space them. It's not going to be perfect. 1, 2, 3, 4, 5, 6, 7, 8. I like to go with 8. I think that's a good distance or good amount of increments. Okay, definitely not the best axes ever, right? But I know that my function has 0, comma, negative 1. So let's go to 0, comma, negative 1. That's where my point's going to be. Okay, and then it says from here, at negative 1, right here, at x equals negative 1, is where my graph is going to break off, okay? So let's graph in purple. So the parameter is if as x is approaching from the right of negative 1, my graph is going to be 2x minus 1, okay? So here I have 2x minus 1, or I have negative 1. I'm going to go down, I think 2, 1, 2, and go to the left once. So that's the right side of my graph. That's y is equal to 2x minus 1. I'm sorry, yeah? I'm sorry, what? Huh? There's not a little line underneath you didn't close it. Oh, I see. Yeah. That should be an open circle. You're correct. Because technically there's no less than or equal to or greater than or equal to. So when we approach that, that shouldn't have an actual inherent value. It's not owned by this line here. Very astute observation. Okay. And the next one over here is going to be x minus 1. So I think we'll start from here. Let's see. And then actually what I'm going to do now is I'm going to plug in, let's just plug in this point here, -3. So in my other one, I'm going to just do this to the side. I'm going to do y is equal to -3 minus 1. And then that will give me -4. So that tells me at -3, I should have a y value of -4. So I'm going to go down once more. There we are. So I'm going to connect these two dots, and then that should give me the rest of the graph. Let's see, 2x minus 1 at 1. Yeah, it's at -3.
But on the other one, but at x minus 1, then it would be -2.
Oh, would it be? Let's see. That's very odd. So that means I did my math incorrectly somewhere. Where did I do that? So let's see. This is y is equal to 1, 0, -1, plus 1, x minus 1. Okay, and then add -1 here. Huh, that's absolutely correct. I wonder why that worked out that way.
Put 0, -1 at the point.
Yes.
Both touch each other at 0, -1. It's just that at -1 they don't.
Huh, that's super odd. Okay, well, just for now, Stephanie, okay? This is the general idea of what I'm looking for the piecewise functions at this point, okay? All right, I'll take a look at that in a second, Stephanie. I'm sorry. Okay, so this is what the actual f of x looks like piecewise. And in case you're curious, the parameters that they gave you, so this is what we solved for here and here, okay, on the bottom in purple and green. The original graph, which was the 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. Do this really quick, and we're talking about -1 here. So for the f prime of x, the actual slope, okay, we had, let's see, so at -1 here, we had here. Sorry, it's not perfect, but this was the f prime of x. So you have a piecewise function that gives me the slopes. So this had the slope of, let's see, I'm sorry, that's not perfect, but 1. And this had a slope of 2 as this is less than -1. The x value, they're approaching the -1 value here. So this line represents a line that for all values where x is less than -1. And this represents all values that are greater than -1. So this should be an open circle. I'm sorry. And again, you don't have to write that. So both of these should be open circles. I did that incorrectly. So that's the f prime of x. That's the slope values. And if you actually graph them out, what you ended up getting was 2 linear lines with slightly different curves, or with slightly different slopes. And as you can see, this does have a slope of 2, and this has a slope of -1. Or I'm sorry, +1. +1, -1. Okay? You guys ready to try your own now? You don't have to graph all that, okay? You don't have to graph all that. I'm just looking for the math here. Here is what you're going to do. So here's your example problem. Your example problem that you're going to have to do on the board is, if I gave you the f prime of x is equal to 2, comma, x is less than 2, and then -1, comma, x is greater than 2, find the equations. So I just asked you to find the equations for both lines. Oh, and they gave you the parameter that f of 0 is equal to 1. Find the equations for both lines for me. Find a space on the whiteboard now and work with a partner, okay? Yes, Ashlyn? I'm sorry, what? Yeah, I'm so sorry. Yeah, it looks like a weird backwards L, but it's my attempt to write -1. A very sad attempt. All right, guys, give it a try. Oh, I apologize, guys. Yeah, my phone's been going off this whole time. Uh, uh, I don't want the board anymore. That's not good. Are you guys finished already, Joseph? Yes. Oh, okay. I'll freeze this for a second. No, it just does that once in a while. All right, when you're finished, go ahead and have a seat back, and then just relax for a little bit. And then I'm gonna unfreeze the screen so you can check your work. Does anybody have any questions so far? All right, good job, Sean. Very good. Okay, so traditionally, what we would say is that this f of x, or what you guys created here, it has a derivative, right? So if we look at this line here, like the original one that I drew. Wait, what? For oh, it's negative. Sorry, it's negative 3 comma negative 4. For which one are you talking about? Oh, it looked like a negative 1. Is that what you're saying? Okay. So yeah, I know it's easy to get caught up in that. What I wanted to teach you guys was, even though that was a piecewise function, traditionally, if your derivative, your slope of this guy and this guy comes from both sides, and they don't have a similar derivative, or they don't have a similar slope. This guy has a slope of 1, this guy has a slope of 2. The overall limit, or the overall slope, technically doesn't exist. And then you can see that literally because when we finally look at the overall graph, they're not continuous at all. The derivatives are not continuous. So traditionally speaking, this graph does not have a derivative at x equals negative 1. The slope, the actual derivative at this point, is missing. Do you guys see that? It's actually an open hole. There is no actual slope at this point, because from both sides, they have to agree. This slope has to be the same as this slope at this particular point, and they're not. And you can kind of see it here because the slope graph is not continuous. It should be continuous if that was the case, but it's not. So that leads me to my next point. Still in 3-1 or 3.1, we're talking about one-sided derivatives. I'm going to go back to using the old notation because we're going to do some, not high-level math, but pretty fast-paced math. And in case you want to know, this was grabbed from page 106, example number 6. And it also has to do with number 31 and 32, in case you're familiar. Or you're not familiar, but you're curious about this. Here's the example problem for a one-sided derivative. It will ask you to show that the following functions have a left hand and right hand. So what I was telling you about two sides coming to meet at some point, that's a left hand and right hand, or in this case, in the way you're looking at my hands, the left hand and the right hand have to meet and have the same slope. The left and right hand derivatives at point x equals 0, okay? At x equals 0, so the following functions have left hand and right hand derivatives of x equals 0, but no overall similar derivative at x equals 0. And then this will be shown as this. I'm going to say that this is f of x is equal to, sorry, I'm going to fix my note here. F of x is equal to, it's a piecewise. It looks like a piecewise, but let's see if each of these pieces have a similar derivative value. And this is going to be 2x, x is greater than 0. So for the last equation, I asked you to make actual f graphs. And then my last problem gave you f prime. This is different. This is not giving you f prime. This is straight up just giving you just f. It's just giving you the original. So this is a different problem. Don't try to make a relationship to the last problem too much, okay? So again, this is the original, like y is equal to or f is equal to equation, right? And I wrote a note to myself to show you something in the book before we move on here. 106, 3.4. Okay, so I'll leave that be. So here's the answer. I guess I'll write the answer in green. I like green. So first we take the left-hand derivative. Let's take the left-hand derivative. And then this is what I mean by the left hand. So I'm going to kind of put a green star next to it, color code it. You don't have to do that, but I just want to color code it so you know what I'm doing. So what I'm going to do to find the derivative is this technique. This is h approaches 0, and let's say we're doing it from the left-hand side, which comes from the negative numbers, okay? Or comes from the negative numbers. And then you're going to do f of x plus h minus f of x of over h. And then you're going to use the left-hand equation, which is this guy, x squared. So in here, you should have x plus h squared, okay? In place of x, you're going to put x plus h, so it's the whole thing squared now, minus x squared over h. And then conveniently, you should have, or actually, I forget, you do need to expand this out, but, oh, I'm going to use this to my advantage because I don't want to do too much work. It's given that x is already equal to 0, so I'm going to do myself a favor. You can do this sometimes, okay? It doesn't always work out, but if they give you an x value, you can just plug in the x right away, the x value of 0. Whoa, what the heck happened there? That's not too good, right? Right. Huh. Okay. Oh dear. Yeah. This is a state of emergency for our technology. It's not always working very nice. Okay. All right, we'll take a little talky break here right now because I know sometimes it gets really dry to listen to me talk up here. Also, are you guys caught up on the videos? I posted up like a bunch of videos on Sunday. Okay, I would highly recommend that you watch those because it's all stuff that I'm gonna eventually test you on, as well as stuff that's gonna help you for the homework. The stuff that I emphasize is really important. Okay, let's see if everything's okay here. That doesn't sound good. Okay. Let's see if this works here. Okay, that's a good sign. So give it a few seconds to reboot. Okay, and let's maybe replug that in here. Okay, that looks pretty good. Okay, so go ahead and write those notes down. I just added a few more things there. So try to multitask as I explain. X is equal to 0, so I got kind of lazy there. I'm like, oh no, I don't want to do x plus h times x plus h. That means I got to expand it out. That'd be like x squared plus 2xh, and I don't want to have to go through all that. I just plugged in my x right away. I knew that x is equal to 0, we're looking at that point, so I just plugged in 0 there. You don't have to do that, but eventually you're going to have to plug in x, right? So why not just do it now? And I found out the limit is equal to 0. That's the left-hand derivative. So they're saying from the left hand, as you approach x equals 0 from the left-hand side, you find that the derivative is 0. Now we're going to take the derivative of the right-hand side, the right-hand derivative. the right-hand derivative. And we're going to use, I'm going to color code this to be purple, 2x. We're going to use 2x. So it's the same concept, the limit as h approaches 0, but from the positive side, the right-hand side. And we're going to do the same thing, f of x plus h minus f of x. This time, our f of x is no longer x squared, but since it's coming from the right-hand side, we're going to use 2x. So that's going to give me 2 times x plus h. So where that x was now is in place of x is x plus h, minus 2 times x, which isn't anything different from what we had up here. It's just 2x over h. You can plug in 0 if you want right now. Okay, so you can plug in 0. So just to keep consistent with my technique, I guess, I'll plug in 0. So that'd just be 2h, and then, so that's 2 times 0 is 0, 2 times h is 2h, 2 times 0 is 0 again, so all I really have is 2h up there. So I have 2h over h, the h's will cancel out, and then I ask, is the right-hand derivative the same thing as the left-hand derivative? Yes or no? So go ahead and write that down, and then answer me that question. Are these two derivatives matching? Well, are they? Are they the same? Nah. So I say, therefore, have you guys ever seen this? The therefore sign? The 3 dots? You guys have never seen that notation? Traditionally, at the end of proofs, you guys remember proofs though, right? Yes. Traditionally, at the end of proofs, your conclusive statement, the last statement that the way I was taught I had to write in high school, was you put at the end, therefore, whatever you're trying to prove, you put in that last proof statement. Prove that x is equal to 12. And then you say, therefore, x is equal to 12. Well, then I say, therefore, the limit as h approaches 0, the overall limit from both sides. We're not talking about from the left and the right. We're talking about the exact limit of f of x plus h minus f of x over h equals d and e. Have you ever seen that before? No? Never seen d and e before? Because does anybody have an inclination for what d and e? It does not exist. The left-hand derivative exists because it's equal to 0. The right-hand derivative exists because it gives me a real number 2. But if these two numbers do not match, the overall derivative does not exist. And if I try, don't do this, don't draw this, but if I drew this out, the right-hand side would look like a parabola, right? That's closed circle. And the right or the left-hand side would look like a straight line, okay? They might be continuous, but the fact that they have completely different slopes approaching this point means that this has no derivative at this point. So at there, right at x equals 0, at x equals 0, there is no derivative, or basically you say there's no slope. There's no slope there, okay, at that particular point. There might be a slope approaching that point from here. From the right-hand side, it looks like it's a derivative that looks like 0. You guys can see that, right? The slope looks like it's flattening out, right? It's going flat. And over here, it looks like it's totally still 2. But the fact that you have a slope of 2 and a flat slope of 0 here means that the overall slope at that point is non-existent. It needs to agree on both sides, okay? Now I'm going to give you one. So that's generally the pace of my class, right? I do one, and I give you one, and see if you like it or not, right? Same scenario, same directions. You don't have to draw anything. And I'm going to mix it up a little bit, guys. I implore you to find a partner that you have not worked with this whole year. So find at least one person you have not worked with and work with that person. Okay, everybody get up. Just go ahead and scour the room and find someone to work with. I would suggest working with Gabby because she has a great looking dog to pet, right? So why not? It's a nice dog. It's a nice doggy. Nice doggy. Nice doggy. Elena, work with Gabby. Yeah, come over. Gabby, you can work with Elena. Is up. Okay. Stevie, you work with Sean. And I think we have partners here. And then okay, you two, and then you two. Perfect. Good. That works. That works. I like it. Greta and Max, how about you guys work over here? So it's a triage because there's not a lot of room right now. So I want as much room as I can get. So Stephanie, you have 2 new partners. Sorry to arbitrarily just set you guys up like that, but yeah, you guys could turn on the lights. Sean, why don't you turn on the lights for me? Okay. Thanks, bud. Sarah, I apologize if this thing's just been blocking my face. Whenever I talk to people, I know it's kind of hard to make out, but I zoomed in a little bit. A manual zoom in. How's your foot, Greta? What happened again?
I had surgery.
Oh, that's right. Yeah. I saw you on Turner Fight. Yeah, or I think the parent. Yeah, Turner Fight or parent conference, or not parent conference. You know, huh? Someday I saw you. Was it broken or what did they have to?
No, I had a bunion or hole, so they had to like fix it.
Oh, okay.
And they had to like, yeah.
Did it hurt afterwards when you woke up?
No, since my whole foot was numb, I couldn't feel anything, and then like after 2 days, it started to hurt, but it wasn't too bad.
Okay, because I think it runs in my family. So my mom had a date recently. I'm looking at my family. I feel like I have one.
Yeah, genetics. My grandmother.
Yeah.
Side.
I'm freaking out over it. I don't like sharp. I hate shots. I'm always the last person to get immune, but now that I'm a teacher, probably should. Or else, my students will suffer from my irresponsibilities and my scared fears. My fears. Yeah, right.
Yeah, it's just a lot of effort. Not very much.
Remember, if you get lazy and you don't want to expand things out, you can plug in the X value.
I don't remember what it is.
You can unleash the theory by just plugging in X at some point. Yeah, the X equals 1. So don't forget, at some point, you know that X is equal to 1. You're looking at it at... Oh, yeah, X is equal to 1. Because they're approaching 1 from both sides, so we're looking at that derivative at X. My apologies. I was not very clear on that. Sorry. Window. Yeah, you guys got it. Does not equal anything.
Yeah.
Overall.
Was I get the formatting right? Like writing it down here? Like that's right format?
You put the limit. Yeah, you can just say that. Limit as expression. That works for me. As well, your
How did you plug in zero? Because it's like the load as an exponential, and then because it's with the so okay. H remember approaches zero, so like H equals zero now, and so that's from like the limit thing. Yeah. Yeah, so if you put x equals zero, H equals zero now, but you still get the root. So you get a real number, so you're good. So it's like
She does bark, but like not very much. Yeah, she's pretty quiet. It's not. She used to not be able to like.
Oh dear.
Alright. She's like a different dog. She's got so much like sugar. Realistically, beautiful. I love her.
you guys did you have to ask her?
Yeah, I looked at her once a week. I was like, going through like women's she was like, no, yeah. She's like, okay. Yeah.
I forgot the dog was there.
No, I think it's hilarious.
And while I also
She's like, one of my allergies is like, I thought I didn't have food. And he's like, oh, you're fine. Yeah, just bring her in.
just like just a little bit. I mean, should be on the floor is great. Not gonna knock you for that.
She's not.
The time and place.
No,
There's we all know that gold here.
guys, good. Like,
Here,
here's like that.
like 5 years. Because he would know.
Casey, go say hi. You're gonna have to fight me for her. And I do have Carter for like,
But they
never
just
beat, but like, I have dog withdrawal. What? No, she just. Well, also she doesn't like cameras. So, no, she hates like you can't. If you want to take a picture, you have to like go like make like like Pixie, come here, and then like as soon as she turns to take a picture, she'll immediately look away. Like she won't look at the camera. It's so funny. I don't know why. See, Sparkle loves cameras. Like she loves them. Taking the Pixie does not. Pixie wants to say hi to Gray. Gray is not responding. Pixie now is sad. Mom was texting me like, yo, is she being okay? Mom was texting me like, oh, is she being okay? Is she like barking? I'm like, no, she literally is the chillest dog ever right now. She got so excited because she was going to the car. She was like, can I go for a ride? She got all wiggly and was like super excited.
Does she wag her whole body?
If she gets really excited, yeah.
Like my dog gets so excited that he uses all coordination in his tail and instead of
Emily, can you get the door again?
My dog doesn't have a tail, so he just has to shake his butt.
Oh, yeah.
Yeah, my dog, they clip his tail so he has.
Oh, sorry, the lights, not the door. Thank you.
Is that toy box dirty?
Okay, if you check your answers, let me see if I got this correct. I don't think I did. Yeah, I think, what is it? Left hand.
We didn't talk to the but it just stopped her.
1 plus
What are
H.
you going to do about
See the left hand. Did anybody get 3 for their left hand? Yeah? Okay, so for the left hand derivative, we got 3. I think, what did you guys get for the right hand derivative? You guys got so this is the left hand derivative. You can check your work. You should have gotten 3. Oops. Okay, so now we're looking at this, and you have your limit from the left hand should have been 3. And how about your right hand? What did everybody get from the right hand? Let me see. All right, maybe I did something wrong here. Yeah, I think I did. Yeah, x squared plus, yeah, the right hand, I'm sorry, is right here, x squared plus x. Wait, I think I did something wrong, guys. Oh, yeah. I'm sorry. So, hold up. Let me go back. I'm sorry. I believe this should have been my right hand, correct? So, sorry. I think I made a mistake. This should be my right hand. Did everybody get the right hand as 3 or no? Yeah? Yes? Okay, so let's see, I got the right hand is 3, and I have a feeling I did the left hand incorrectly. So the left hand would be 3x minus 2, right? So let's double check my work here. I'm going to start from scratch again. I don't think I did that correct. So this is the left hand. That is, what is it? That is the limit as h approaches 0 from the negative side of f of x plus h minus f of x over h, which I believe is, what is that? 3x minus 2, right? So it's 3 times x plus h minus 2 minus 3x minus 2. Is it 3x plus 2 or minus 2? Is it 3x minus 2 or is it 3x plus 2? Minus, okay, thank you. That would give me 3x plus 3h minus 2 minus 3x plus 2, which would give me all over h. These would cancel out. The 2's would cancel out, giving me 3h over h, which gives me 3. Oh, let me double check here. Yeah, I guess so. I guess if this matches, I don't know if I did my math correctly. I thought it shouldn't match, but in this matches, whether I made a mistake or not, I feel like I made a mistake here. But as far as my answers go right now, the limit does exist. The limit as h approaches 0 is equal to 3. Or the limit, yeah, the limit as h approaches 0 is equal to 3, or you could say the derivative, therefore the derivative at x equals 1 is 3. You can write it both ways. Okay, I'm going to double check my work though. Otherwise, as far as I could tell, I don't think anyone has a misunderstanding of what to do. Okay, so once you guys pack up, there will be a video, so on 3.2, and be on the lookout for that. You guys have a great day. Have a good day, guys. What did I do wrong here? All right, and please stack back your chairs. Thank you. That was very, very nice of you guys. Thank you guys so much.